Hello, in this lecture we will find the radius of a circle. In the drawing we have a circle. The center of this circle is at point O. Chord AD equals to 10 units and chord BC equals to 5 units, and this angle equals to 90 degrees, and we want to find out the radius of this circle. First of all, we will define the term peripheral angle. Okay. A peripheral angle is an angle inside the circle that its vertex is on the circle, that its vertex a peripheral angle is an angle inside the circle that its vertex is on the circle, and its curves are chords in the circle. So I will read again the definition of a peripheral angle. A peripheral angle is an angle inside the circle that its vertex is on the circle and its curves are chords in the circle. Okay, so now I will give you an example of a peripheral angle, and I will explain the definition of a peripheral angle. Angle alpha in the drawing is a peripheral angle because its vertex is on the circle. Its vertex is at point A, and point A is a point on the circle, and its curves are chords in the circle. Curve AB of angle alpha is chord in the circle, and also curve AC of angle alpha is chord in the circle. And also we can say that the peripheral angle alpha rests on chord BC. Okay, peripheral alpha, angle alpha, the peripheral angle alpha rests on chord BC. Again, the peripheral angle alpha rests on chord BC. Okay, again, a peripheral angle is angle inside the circle. Angle alpha is inside the circle, and the vertex of angle alpha is at point A, and the point A is point on the circle itself, and the curve AB of angle alpha is also chord in the circle, and curve AC of angle alpha is also chord or string in this circle. Okay, so that is the definition of peripheral angle. Okay. In the next step, we will draw a chord through points A and O, so I draw a chord through points A and O, and we will call to the touching point between the circle and the chord point M. Again, point M is the touching point between the chord and the circle. Okay? And you should remember the chord AM passes through point A, that is the center of this circle. So we actually can say that chord AM is the diameter of this circle. So I write it down. Chord AM is the diameter of the circle. Okay, chord AM that I drew is the diameter of the circle, because of the fact that it passes through point O, that is the center of this circle. Okay, because of the fact that it passes through the center of the circle. The center of the circle is point O. Okay? Okay? I will read again. Okay. What chord AM is the diameter of the circle because of the fact that it passes through the center of the circle, that is to say through point O. Okay? Any chord that passes through the center of a circle is defined as the diameter of that circle. And chord AM passes through the center of the circle, that is to say through point O. For that reason, AM is the diameter of this circle. Okay, in the next step, we will connect together by a straight line points D and M. Okay, we connected together points D and M. We have a rule, I will call it rule number 1. Rule number 1 states that a peripheral angle that passes a peripheral angle that rests on the diameter of a circle equals to 90 degrees. So I will read again rule number 1. Rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. again, rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. So I will give you an example in order to clarify rule number 1. If for example chord AB is the diameter of this circle, so this is the center of the circle, so this is the radius and this is the radius also. Any peripheral angle that rests on the diameter, that is to say on chord AB, will be equal to 90 degrees according to rule number 1. So actually, if we have peripheral angle the peripheral angle ACB rests on chord AB and AB is the diameter of the circle. Therefore, according to rule number 1, peripheral angle ACB equals to 90 degrees. I will read again what I wrote. So angle ACB rests on chord AB, and chord AB is the diameter of the circle. Therefore, according to rule number 1, angle ACB equals to 90 degrees. So actually, angle ACB equals to 90 degrees according to rule number 1. Again, any peripheral angle that rests on the diameter of a circle equals to 90 degrees. Okay, now we will return to our drawing. Angle ADB rests on chord AM Okay, angle ADB rests on chord AM, and chord AM is the diameter of the circle. Therefore, according to rule number 1, angle ADB equals to 90 degrees. I will read again what I wrote. So, angle ADB, rests on chord AM. As you can see, angle ADB rests on chord AM. And chord AM is the diameter of this circle because it passes through point O, that is the center of the circle. So because of the fact that angle ADB rests on the diameter of this circle, it equals angle ADB equals to 90 degrees. So angle ADB equals to 90 degrees. Okay, this angle equals to 90 degrees. Because of the fact that it rests on AM, that is the diameter of this circle. In the next step, we will define in the right triangle, we will focus on the right triangle ADB. And actually in the right triangle ADB, we will define angle AMD as angle alpha, and angle AMD, angle MAD is angle beta. Okay. So I'll write it down. Angle AMD equals to alpha according to our definition. And angle MAD equals to beta. So according to our definition, in the right triangle DAB, angle AMD equals to alpha, and angle angle AMD equals to alpha, and angle MAD equals to beta. So angle AMD equals to alpha, and angle MAD equals to beta. Okay. Now we will connect points A and B together by a straight line. And we actually have rule number 2. Rule number 2 states that if two peripheral angles rest on the same chord / arc, they are equal to each other. So I will define again rule number 2. Actually, I will give you two different definitions. They are actually, the meaning of those two definitions will be the same, but they are actually expressed differently. The first definition of rule number 2 is that if two peripheral angles are equal to each other, I made a mistake. If two peripheral angles rest on the same chord, then they are equal to each other. So I will read again rule number 2. Rule number 2 states that if two peripheral angles rest on again, rule number 1 states that if two peripheral angles rest on the same chord, then they are equal to each other. First of all, I will give you an example in order to clarify the rule, the meaning of the rule, rule number 2. So actually we have two peripheral angles that are equal to each other. We have peripheral angle actually we have two peripheral angles that rest on the same chord. So we have peripheral angle alpha, and we have the second peripheral angle beta, so we have peripheral angle alpha that rests on chord BC, and we also have peripheral angle beta that also rests on the same chord BC. So according to rule number 2, that states that if two peripheral angles if two peripheral angles rest on the same chord, then they are equal to each other. So we have those two peripheral angles alpha and beta that rest on the same chord BC. Therefore, according to rule number 2, they are equal to each other. That is to say, angle alpha equals to angle beta. Okay, so I write it down. First of all, I will write that alpha and beta rest on the same chord, that is to say chord BC. Therefore, according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. Or angle alpha equals to angle beta. Okay, alpha equals to beta. So I will read again the things that I wrote. Alpha and angle alpha and angle beta rests on the same chord BC. Therefore, according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. So because of the fact that those two peripheral angles, alpha and beta, rests on the same chord BC, according to rule number 2, they are equal to each other. that is to say alpha equals to beta. Okay? Okay? Because of the fact that angle alpha and beta rest on the same chord BC, they are, according to rule number 2, they are equal to each other. Therefore, that is to say, alpha equals to beta. Okay, so we can actually implement rule number 2 in our circle. Angle AMD, that is actually angle alpha, rests on chord AD. As you can see, angle AMD, that is angle alpha, rests on chord AD, and the peripheral angle ABD also rests on the same chord AD. So, according to rule number 2, angle ABD equals to angle alpha. Okay, so I write it down. Angle AMD that equals to alpha rests on chord AD, and angle ABD also rests on chord AB. Angle ABD also rests on chord AD. Okay, angle AMD that equals to alpha rests on chord AD. Angle AMD that equals to alpha rests on chord AD, and angle ABD also rests on chord AD. Therefore, according to rule number 2, those two angles are equal to each other. That is to say, if this angle equals to alpha, also angle ABD equals to alpha. Okay? So angle AMD that equals to alpha rests on chord AD, and angle ABD also rests on the same chord AD. Therefore, according to rule number 2, they are equal to each other. So if this angle is alpha, this angle is also alpha, because both those two angles rest on the same chord AD. So if this angle equals to alpha, this angle also equals to alpha. That is to say, angle ABD equals to alpha. Okay, so angle ABD equals to alpha, so I will write here that this angle is angle alpha. Okay, I will read again the diagram. Angle AMD equals to alpha. Angle AMD equals to alpha. And angle AMD that equals to alpha rests on chord AD. Angle AMD that equals to alpha rests on chord AD. And angle ABD also rests on chord AD. Angle ABD, that is a peripheral angle, rests on the same chord AD. Okay, both those two angles rest on the same chord AD. Therefore, according to rule number 2, they are equal to each other. Okay? Therefore, according to rule number 2 that states that if two angles rest on the same chord, they are equal to each other. So according to this rule number 2, they are equal to each other. That is to say, angle ABD also equals to alpha. Angle ABD equals to alpha. Okay? I write it here again. Angle ABD also equals to angle alpha. So according to rule number 2, because of the fact that those two angles rest on the same chord AD, they are equal to each other. That is to say, angle ABD equals to alpha, according to rule number 2. Okay, so angle ABD equals to alpha. Now we will focus on the right triangle AB. First of all, we define the vertex of the right angle. The vertex of this right angle will be defined as L. So, in the right triangle ABL, we'll focus on the right triangle ABL. We will define angle BAL as X. Okay? Angle BAL will be defined as X. Okay? This angle is defined as X. Okay? I write it down. Angle BAL equals to X. So in this right triangle, the sum of its angles equals to 180 degrees. It is true for all the triangles in the world, and especially it is true to the right triangle ABL, that the sum of its angles equals to 180 degrees. That is to say, the sum of the angles of the right triangle ABL is actually x plus alpha plus 90 degrees. X plus alpha plus 90 degrees equals to 180 degrees, according to the rule that it is true for all the triangles in the world. The sum of the angles of any triangle equals to 180 degrees, and especially it is true to the right triangle ABL. So the sum of the angles in the right triangle ABL, that is x plus alpha plus 90 degrees, equals to 180 degrees. That is our first equation. From the first equation, we will subtract 90 degrees from equation number 1. So we subtracted 90 degrees from equation number 1 here. So x plus alpha plus 90 degrees minus 90 degrees equals to x plus alpha, and 180 degrees minus 90 degrees equals to 90 degrees. Now we'll subtract alpha from this equation. Actually, we will return to the right triangle AMD. We defined angle AMD as alpha and angle MAD as beta. Okay, angle AMD equals to alpha and angle MAD equals to beta, and actually the sum of the angles in the right triangle AMD equals to 180 degrees. So equation number 1 is actually alpha plus beta plus 90 degrees equals to 180 degrees. Okay, the sum of the angles of any triangle in the world equals to 180 degrees, and especially in the right triangle AMD, the sum of its angles equals to 180 degrees. So alpha plus beta plus 90 degrees equals to 180 degrees. We will subtract alpha from the equation. From equation number 1, we will subtract 90 degrees from equation number 1. So we subtracted 90 degrees from equation number 1. We got that alpha plus beta equals to 90 degrees. Now we'll subtract alpha from this equation. We will get that beta equals angle beta equals to 90 degrees minus alpha. Okay, so this is our first equation that states that beta equals to 90 degrees minus alpha. Okay, and as we relate on the right triangle ABL, the equation that we created will be equation number 2, because we have already equation number 1 as we dealt in with the triangle AMD and the right triangle AMD. So here it will be the second equation. Okay, so we got that x equals to 90 degrees minus alpha. Okay, we subtracted alpha from equation number 2. We got x plus alpha minus alpha equals to x, and 90 degrees minus alpha equals to 90 degrees minus alpha. So from equation number 2 we know that x equals to 90 degrees minus alpha, but equation number 1 states that x equals that beta equals also to 90 degrees minus alpha. According to equation number 1, beta equals also to 90 degrees minus alpha. So I write it down. So equation number 2 states that x equals to 90 degrees minus alpha, and equation number 1 states that beta equals to 90 degrees minus alpha. From that we can deduce that x equals to beta, but if you want to do it in the long way, I will show you. So 90 degrees minus alpha equals to 90 degrees minus alpha. We'll subtract 90 degrees minus alpha from this side of the equation by x, because x equals to 90 degrees minus alpha. And then from this side of the equation we will subtract 90 degrees minus alpha by beta, because beta equals to 90 degrees minus alpha. Okay? We will get that x equals to beta. Okay? We subtracted 90 degrees minus alpha by x, because x equals to 90 degrees minus alpha, and we subtracted 90 degrees minus alpha on this side of the equation by beta, because beta equals to 90 degrees minus alpha. We got that x equals to beta. Okay, so actually we found out that x equals to beta. So instead of x, I can write here beta. Okay, so actually we have angle BAL or BAC that equals to beta, and angle MAD also equals to beta. And we have actually rule number 3, that states peripheral angles that equal to each other that are equal to each other rests on equal chords. So I'll read Rule number 1 again. Rule number 3 again. Rule number 3 states that peripheral angles that are equal to each other rest on equal chords. I will give you an example for rule number 3 in order to clarify the rule. Actually, if we have two peripheral angles that are equal to each other, for example, this peripheral angle is alpha, and this peripheral angle is also angle alpha. So, because of the fact that those two peripheral angles are equal to each other, they rest on equal chords. That is to say, BC equals to EF, but again, peripheral angle alpha in the red color rests on chord BC. Okay, red alpha rests on chord BC. Peripheral angle alpha in the black color, black alpha rests on chord EF. Okay, the black peripheral angle alpha rests on chord EF. So, according to rule number 3, because those two angles are equal to each other, they rest on equal chords. So, according to rule number 3, because they equal to each other, alpha equals to alpha, they also rest on equal chords. That is to say, BC equals to EF. So I will read again the things that I want. So red alpha rests on chord BC. This angle rests on chord BC. And black alpha, the black angle alpha rests on chord EF. According to rule number 3, because they are equal to each other. According to rule number 3, because those two angles are equal to each other, that is to say, angle alpha in the red color equals to angle alpha in the blue color, they also rest on equal chords. That is to say, BC equals to EF. BC equals to EF because of the fact that those two angles are equal to each other, they both rest on equal chords. That is to say, BC equals to EF. So this is the explanation of rule number 3, and we actually can implement rule number 3 in our circle. Angle BAC equals to beta. That is what we found out, that angle BAC equals to beta. And angle BAC rests on chord BC. Okay, angle BAC equals to beta, and it rests on chord BC. And angle MAD also equals to beta. And angle MAD that equals to beta rests on chord MD. Therefore, according to rule number 3, or because of the fact that those two angles are equal to each other, according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Okay, so I'll read again the things that I wrote. Angle BAC equals to beta. Angle BAC equals to beta. And it rests on chord BC. Angle BAC rests on chord BC, or angle BAC that equals to beta rests on chord BC. Angle AMD that equals to beta, angle AMD equals to beta, and it rests on chord MD. Angle MAD that equals to beta rests on chord MD. Okay, chord MD. And because of the fact that those two angles are equal to each other, angle BAC equals to beta, and angle MAD also equals to beta, so those two angles are equal to each other. So because of the fact that those two angles are equal to each other, they both equal to beta. According to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Because of the fact that those two angles are equal to each other, they both equal to beta. They rest on equal chords. That is to say, this angle beta rests on BC, and this angle beta rests on MD. And according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. Okay? Again, because of the fact that those two angles are equal to each other, both of them equals to angle beta, they also rest on equal chords. This angle rests on BC, and this angle rests on MD, and according to rule number 3, they rest on equal chords. So BC equals to MD. Okay? So according to rule number 3, because of the fact that those two angles are equal to each other, they rest on equal chords. That is to say, BC equals to MD. Okay? But we know that BC equals to 5 units. It is given us in the question. We know that BC equals to 5 units. It is given us in the question that chord BC equals to 5 units. So we can deduce from those two expressions, BC equals to MD and BC also equals to 5 units, that MD also equals to 5 units. So if you want, I will show you that we can write that BC equals to MD equals to 5 units. Okay, we combine these two expressions together. BC equals to MD and BC also equals to 5 units. So we can deduce from it that MD also equals to 5 units. Okay, we can deduce from it that MD equals to 5 units. Okay, MD equals also to 5 units. Okay, so we can write here that MD also equals to 5 units. Now I will draw the right triangle AMD again. So actually side AD of the right triangle MAD equals to 10 units, side MD of the right triangle MAD equals to 5 units, and AM is the diameter of the circle, so we can name side AM, that is also the hypotenuse of the right triangle AMD. We can call it D, abbreviation for the diameter of the circle. Okay, we have here right triangle. We know the size of two sides of this right triangle. The only missing thing is the size of the hypotenuse. So we can find out the size of the hypotenuse by using the Pythagorean theorem. Actually, the Pythagorean theorem states that in a right triangle, because the Pythagorean theorem applies only to right triangles. So it must be a right triangle. In a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I read again the Pythagorean theorem. The Pythagorean theorem states that in a right triangle, because it's correct only in right triangles, so it must be a right triangle in order to use the Pythagorean theorem. In a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so we can implement the Pythagorean theorem in our right triangle. The square of the hypotenuse, that will be our third equation. The square of the hypotenuse, that is to say AM square, equals to the sum of the square of the perpendiculars. That is to say equals to AD square plus MD square. Okay, so in a right triangle, in our right triangle, AM square equals to AD square plus MD square. But we know that AM equals to D. Yes? AM is the diameter of the circle, it equals to D. AD equals to 10 units. And MD equals to 5 units. Okay? MD equals, AM equals to D, AD equals to 10 units, and MD equals to 5 units. So we can substitute AM by D, AD by 10, and MD by 5. Okay? So we got that d square equals to 10 square plus 5 square. 10 square is 100, 5 square is 25, 100 plus 25 equals to 125. Okay, d square equals to 125. Now we will take a root out of equation number 3. So we got that d equals to root of 125. We know that 125 equals to 25 times 5. So we write it down. Okay, instead of 125, I wrote 25 times 5 because it equals 125. Now we can split the root to two roots according to the rule that so we can split the root to two roots according to the rule that the root of a times b equals to root a times root b. So we will get that we split the root to two roots. Instead of root of 25 times 5, we got that d equals to root 25 times root 5 according to the rule that the root of a times b equals to root a times root b. And the root of 25 is 5, so I will write it down. So root of 25 is 5, so we got that d equals to 5 times root 5. But we also know that the diameter of any circle equals to 2 times the radius. Okay? We know that the diameter of any circle equals to 2 times the radius. It is true for all the circles in the world. Okay? So, actually we can substitute d in the fourth equation by 5 times root 5 because d equals to 5 times root 5. So we substituted d by 5 times root 5. We got that 5 times root 5 equals to 2 times the radius. We will divide equation number 4 by 2, and we will get that the radius of the circle equals to 5 times root 5 over 2. Okay, we divided equation number 4 by 2, and we got that the radius of the circle equals to 5 times root 5 over 2. Or we can write it in terms of numbers. Or the radius equals to 5.59 units, or we can also say that the radius of the circle equals to 5 times root 5 over 2 units. Okay, so actually that is the answer to the question, that the radius of this circle equals to 5.59 units, so it equals to 5 times root 5 over 2 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the radius of this circle. The center of the circle is at point O. Chord AD equals to 10 units. Chord BC equals to 5 units. And angle ALB equals to 90 degrees. Okay, first of all, we define what is a peripheral angle. A peripheral angle is an angle inside the circle that its vertex is on the circle and its curves are chords in the circle. So you can see an example of a peripheral angle. A peripheral angle is an angle that is on the circle. Angle alpha is a peripheral angle because it is on the circle, inside the circle, and the vertex of angle alpha is at point A, and point A is also a point on the circle itself. And curve AB of angle alpha is also the chord of in the circle, and also curve AC of angle alpha is chord in the circle. For that reason, angle alpha is a peripheral angle, and also angle alpha, peripheral angle alpha, rests on chord BC. Okay, so that is an example of a peripheral angle. Again, a peripheral angle is an angle inside the circle. Angle alpha is inside the circle. Its vertex is on the circle. So the vertex of angle alpha is point A, and point A is a point on the circle itself, and its curves are chords in the circle. Curve AB is chord in this circle, and curve AC of the angle alpha is chord in the circle. Okay, so that is the definition of a peripheral angle. In the next step, we drew chord through points A and O. Actually, point O is the center of the circle, and the touching point of the chord with the circle is at point M, and actually chord AM is the diameter of the circle because of the fact that it passes through the center of the circle. That is to say, it passes through point O, that is the center of the circle. For that reason, chord AM is the diameter of this circle. We have rule number 1 that states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. So actually we have an example of a peripheral angle. Suppose that chord AB is the diameter of this circle. Then, as you can see, chord ACB rests on chord AB. Again, angle ACB rests on chord AB, that is the diameter of this circle, and therefore according to rule number 1, angle ACB equals to 90 degrees. Okay, this is the explanation of rule number 1. We can implement rule number 1 in our circle because we have a chord AD M that rests on chord AM, that is the diameter of the circle. So, angle ADM rests on the diameter of the circle. That is to say, it rests on AM, that is the diameter of the circle. Therefore, according to rule number 1, angle ADM equals to 90 degrees. Okay? Then we focused on the right triangle AMD. We defined angle AMD as alpha and angle MAD as beta. and we know that the sum of the angles in the right triangle AMD equals to 180 degrees, so we can write down our first equation that states that the sum of the angles in the right triangle AMD equals to 180 degrees, or alpha plus beta plus 90 degrees equals to 180 degrees. Okay, because the sum of the angles in any triangle equals to 180 degrees, and especially in triangle MAD. The sum of its angles equals to 180 degrees. So alpha plus beta plus 90 degrees, that is the sum of the angles in the right triangle MAD, equals to 180 degrees. And we got from equation number 1 that beta equals to 90 degrees minus alpha. Okay, then we have rule number 2 that states that if two peripheral angles rest on the same chord, then they are equal to each other. So actually, to give you an example what rule number 1 means, we have two peripheral angles, alpha and beta, and both of them rest on the same chord BC. Angle alpha rests on chord BC, and also angle beta rests on the same chord BC. So, because of the fact that they both rest on the same chord, therefore, according to rule number 2, they are equal to each other. That is to say, alpha equals to beta. Okay, so we actually can implement rule number 2 in our circle, because we have angle AMD that equals to alpha, and angle AMD rests on chord AD, and we have also angle ABD that also rests on chord AD. Therefore, according to rule number 2, angle ABD also will be equal to alpha, because if you have two angles that rest on the same chord, then they are equal to each other. Angle alpha rests on chord AD, and angle ABD rests also on chord AD. Therefore, they are equal to each other. Therefore, angle alpha equals to angle ABD, or angle ABD equals to alpha. Okay? Then we defined in the right triangle ABL, we defined angle BAL as X. We know that angle ABL equals to alpha, and angle BLA equals to 90 degrees. And we know that the sum of the angles in any triangle, and especially in triangle ABL, equals to 180 degrees. So we can write down our second equation that states that x plus alpha plus 90 degrees equals to 180 degrees, or the sum of the angles in the right triangle ABL equals to 180 degrees. As you can see here, x plus alpha plus 90 degrees, that is the sum of the angles in the right triangle ABL. It equals to 180 degrees. So this is our second equation, and we got that x equals to 90 degrees minus alpha from the second equation. But from the first equation, we have already know that beta also equals to 90 degrees minus alpha. So from equation number 1 and 2, we can deduce, because of the fact that x equals to 90 degrees minus alpha and beta also equals to 90 degrees minus alpha, we can deduce that x equals to beta. Okay, so we can write here, instead x, we can write here that angle BAL equals to beta instead of x, because x equals to beta. Okay, now we have rule number 3 that states that peripheral angles that are equal to each other rest on equal chords. Okay, so I will give you an example in order to clarify rule number 3. If we have two peripheral angles that are equal to each other, the black alpha equals to the red alpha, then according to rule number 3, they rest on equal chords. The red alpha rests on chord BC and the black alpha rests on chord EF. So according to rule number 3, they rest on equal chords. That is to say, BC equals to EF. Okay, so that is the explanation of rule number 3. We can implement rule number 3 in our circle. We have angle MAD that equals to beta, and angle MAD rests on chord MD. And we have also angle BAC that also equals to angle beta, and angle BAC rests on chord BC. So because of the fact that those two angles are equal to each other, they both equal to beta, they rest, according to rule number 3, they rest on equal chords. This angle rests on BC, and this angle rests on MD. And according to rule number 3, because they are equal to each other, they rest on equal chords. So BC equals to MD. Okay, because of the fact that those two angles are equal to each other, they rest on equal chords. This angle rests on BC and this angle rests on MD. They rest on equal chords according to rule number 3, so BC equals to MD. Okay. So BC equals to MD, but it is given us in the question that BC equals to 5 units. Okay, so we can write down that BC equals to MD equals to 5 units, and we can deduce from it that MD equals to 5 units. Okay, this chord MD equals to 5 units. Then I draw triangle AMD again. We have a side AD that equals to 10 units, side MD equals to 5 units, and side AM is the diameter of the circle. I called it D, abbreviation for diameter. And we know that according to the Pythagorean theorem, that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, in our right triangle, the square of the hypotenuse, AM square, equals to the sum of the square of the perpendiculars, equals to AD square plus MD square. Okay? So this is our third equation. Again, AM square equals to AD square plus MD square. But we know that AM equals to D, it is the diameter of the circle. AD equals to 10 units and MD equals to 5 units. So we can put the data in equation number 3 and after we put the data in equation number 3, we got that D, the diameter of the circle, equals to 5 times root 5. But we know that the diameter in any circle in the world equals to 2 times the radius. So we can create equation number 4 that states that the diameter equals to 2 times the radius. But we know that the d equals to 5 times root 5. So we can substitute d by 5 times root 5. So we substituted d by 5 times root 5, and we got that 5 times root 5 equals to 2 times the radius. We divided equation number 4 by 2, and we got that the radius of our circle equals to 5 times root 5 over 2 units. Or the radius of the circle equals to 5 times the radius of the circle equals to 5.59 units. Okay, so the radius of this circle equals to 5.55 units, so we can say also that it equals to 5 times root 5 over 2 units. Okay, thank you very much.